Okay, well, we're here with period 7. Would you like to say hello, period 7, to the rest of the classes there? Hi there, yeah. So, okay, so to go through this, it says, how many moles of potassium chlorate? So this is what we're trying to find. To produce 1.5 moles of oxygen gas. This is the given. I'd recommend you come over here, circle this, label it given. And let's see, potassium chlorate, well, that's potassium chloride, so this must be the potassium chlorate. That's what we're trying to find. And what's really nice with most of these problems on this one, they're a mole-to-mole conversion. You're going to have your given, and all you need to do is multiply it by the moles of what you're trying to find over what you're given. So let's see, we're given 1.5 moles of O2 gas. Group 1, what do we need to put in the denominator down here? We need the moles of what we were given, so we got 2 moles of KClO3. And we're trying to find, oh wait, I got it backwards, didn't I? Now, that's why it's real important to put your unit. If I didn't put the units, and you might have missed it, so I put the wrong one in there. We need 3 moles of O2. So, sorry about that. 3 moles of O2. If I can diagonally cancel, if you can do that, that lets you know you set it up right. And then we were trying to find potassium chlorate. We need the 2 moles of KClO3 up there. And at that point, we're done. It's 1.5 times 2, which is what, 3? Divided by 3. So there you go. So the next problem over here, we've got how many moles of oxygen. Oh, first I'm going to come back and erase this because I've got a new set of givens and finds. Same equation. How many moles of oxygen gas would be produced? So that's what we're trying to find. So I'm going to come back over here now and call this our find. And it's nice, it's moles. We're still just doing moles to moles. Our given is 5 moles of KClO3, so we're given this. So we'll put our given value from here, KClO3. Would you answer that for me and just tell it and take a message? KClO3. That's our given there. Put that over 1. And then we got to do the mole ratio. So how many moles of KClO3 are in the balanced equation? Group 2. How many moles of KClO3 are in that balanced equation? There's 2 moles of that. And we're trying to find oxygen. Group 3, how many moles of O2 are in the balanced equation? Up here, there's 3 moles. Whoops, forgot to put moles. So let's see. The moles of KClO3 cancel out. And what's 5 times 3? And then what's 15 divided by 2? So it'll be that value there. So part C, how many moles of KClO3 are needed to decompose to produce this much oxygen gas? So this is our given because we have a value. This is what we're trying to find. All right, have a great day. So, got a student leaving, that's what the phone call was for. So let's see, we've got O2 is our given, so I'm just going to circle this up there. This is the given. And we're trying to find KClO3. So we've got 11 moles of oxygen gas, O2. Group 4, would you help me out? Since we got moles of O2 up here in the numerator, we're going to need moles of O2 down here in the denominator. From the balanced equation, how many moles of oxygen gas are there? 3. There's 3 moles of O2. And let's see, we're trying to find KClO3. Group 5, how many moles of KClO3 are there in that balanced equation? And we look up there and we got 2 moles of KClO3. So what's 11 times 2 divided by 3? We got what? 22 divided by 3? Okay, 7 something. Okay, now for part D. Part D, how many liters of O2? So now we're going to have to do an extra step compared to the last 3. So we're trying to find liters of O2. So this time I'm going to come up here and circle. We're trying to find O2, and I'm going to put a note to myself, put an L there that we're looking for liters. And we're given 1 mole of KClO3, so this is what our given is. So we'll write down the value that we had, 1 mole of KClO3 over 1. So the first step is we need to convert it into moles of O2. See, group 6, since we've got moles of KClO3 in the numerator, how many moles of KClO3 are there in the balanced equation that we'll put down here? We got 2 moles from the balanced equation of KClO3. And since we're trying to find liters of O2, group 7, would you help us out? How many liters of O2 do we have in the balanced equation? Group 7, how many liters of O2 are in that balanced equation? All right, they have no clue. Group 8, would you look at the balanced equation and tell me what the coefficient is in front of the O2? That'll tell us how many moles of O2. Did I say liters? I apologize, group 7. Let me back up over there. How many moles of O2 are there in the balanced equation? Okay, 3. My apologies. So 3 moles of O2. Now cancel there. I was jumping. Now we've got to go to liters. Group 8. How many liters are there in 1 mole of O2? 22.4 liters of O2. Okay, so now we've got 3 times 22 divided by 2 this time. And that'll tell you how many liters. Let's see, those cancel out. So how many liters of O2 you've got. So, and I'll end it right there.